back to my channel. Today we're gonna solve the min cost to connect all points. Last time on my channel I solved this using crisscross algorithm and union find, and today we're gonna use an algorithm called Prim's algorithm. Basically, Prim's algorithm constructs a minimum spanning tree on a weighted undirected graph. Both Prim's algorithm and crisscross algorithm can construct a minimum spanning tree on a weighted undirected graph, but the difference is for crisscross algorithm, crisscross algorithm goes by edges, but Prim's algorithm, it goes by vertices. What this means is basically for Prim's algorithm, it uses like a BFS structure, and then it also uses a min heap. But for crisscross algorithm, it uses union find usually. And yeah, let's start coding this. So for Prim's algorithm, first we need to construct our adjacency list, and I'm gonna use the help from collections default dictionary. And then also, since we need a min heap, I'm gonna be importing from collections import default dictionary and then import heap q for the min heap. So first let's construct our adjacency list equals default dictionary of lists, and let's go through all the points here. So we want to do something like for I in range length of points, for j in range length of points. We can do I plus 1 length of points. Because we don't want to go through repeatedly, so we can just do I plus 1 each time. So we can do x1, y1 equals points I, and then we can do x2, y2 equals points j. And now we can calculate the cost. So the cost is the Manhattan distance, right? The absolute value of xi minus xj. So we can do absolute value of x1. I like to do x2 minus x1. There's no difference. And then plus the absolute value of y2 minus y1. And here we can append it to our adjacency list. So since it's bidirectional, it's like there's no directions between them. We can, like, all these connect to each other, So we're gonna do it back and forth. Adjacency list I dot append. So for this adjacency list, we can store into a structure. For each one, we can store the cost and then the destination node. So we can append the cost and the destination, which is j. And then we can do the same back and forth. Adjacency list j dot append the cost and then I. So now we've successfully created our adjacency list here. We can start writing our Prim's algorithm. First, for Prim's algorithm, we'll need a visited set where we keep track of all nodes. And keep in mind, if we want to connect everything, make this all 1-bit component. See how many points there are? 1, 2, 3, 4, 5. We need to connect n minus 1 edges, so it's gonna be 5 minus 1, which is 4. We have a visited set, and then what else thingy, we need a min heap. And then we'll initialize our min heap at 0, 0. Like 0, 0 doesn't mean we have like a 0, 0 here. It just means we have a virtual node start at 0 where it connects to itself with 0 cost, right? So this is the cost, this is the destination. The same format as our adjacency list. And we can have a result cost equals 0, and then now we can start writing our Prim's algorithm. Well, let's say length of visited. Well, our visit is less than the length of points, so that means we haven't went through everything yet. We can do a pop, so we can pop the cost and the node equals heap q dot pop, heap q dot heap pop, I think, heap pop min heap. And then if node not in, if node is not in visited, we can add this to our cost. So we can do result add equals cost, and then visited dot add the node. And then we can go through its neighbors like a regular BFS. We have to go through all the adjacency list neighbors, right? So we can do for neighbor cost, and then neighbor in adjacency list node, and if neighbor not in visited, then we can do min heap q dot heap push with our min heap, and we can push on our neighbor. So we're gonna push on the neighbor cost, and our neighbor and finally we're gonna return our result here. From collections, import default, and let's try submitting this. Yeah, so this is how you would write, you would solve this using Prim's algorithm. Please let me know if you have any questions, and thank you so much for watching.